Hey boys and girls, welcome back to Munro Live. I'm here with Cory, and we're wearing the hottest ticket maybe in the world. 200 people got selected to sit in and listen to the shareholders report.
Investor Day.
Investor Day, shareholders report, investor. I don't know what the difference is, but anyway, at the end of the day, Cory and I were there. We didn't have the best seats in the house, but we were very, very grateful to get in. And that's where I want to start off this by thanking Anwar Beck and Matt for getting us into the show, along with a myriad of people in the background. Neither one of those guys got in, along with people like Gally. I don't know if you knew it, but Gally didn't get in either.
Gally was there.
Gally was there, but they escorted him out, and then he got back in somehow. There's a whole bunch of stuff on the. You're supposed to be the internet.
I saw Gally ride the bus with us.
Yeah, I know. But at the beginning, apparently he got in and then was left outside. There's a lot of guys that were fanboys that didn't quite make it. Anyway, the other guy that I gotta thank is Pierre Farragut, and I can't read this. He put down the 5 things that he thought were important about yesterday. Read number 5, because I can't do it. It's like too embarrassing.
Do you want me to read some of the other ones?
Nope, just 5. Well, you can if you want.
I'll paraphrase some of the other ones. His top 5 takeaways are the hybrid model of the low-end car. It'll not apply to the Model 3 or above, where 100% silicon carbide is economically viable. All right, I'm going to skip to the last one. So he has 5 takes. The 5th one is number 5. Sandy Munro is more valuable to humanity than Elon Musk.
And that's why I can't read it, because that's humbling. That's like, I don't want to say ridiculous, but holy mackerel. I feel really in his debt. I can't believe that anybody would write that, but Kim found that.
Yeah. So Pierre was actually on the panel with us afterwards at Clive Bar. Really well spoken. Yeah. We actually interacted with him several times at the Investor Day.
Right.
Well, let's skip right into it, Sandy. Let's get our take on what we saw on the Investor Day. And I'm going to actually give kind of my first take. Is I thought the presentation was extremely technical. And there was a lot of the fine points in there that I think may have gone over the heads of the institutional investors there. Yeah. And let's try and break those down. So the first thing I want to talk about is the little images, the Easter eggs.
Easter eggs, yeah, exactly.
The hairpin
stators.
Yeah. Go ahead, talk about that.
Well, this is something that I've been talking about quite a bit. And in fact, the very first time we actually looked at one of the motors that came out of Tesla, I asked the question, I wonder why they didn't bother going into a hairpin design. Now, they didn't allow us into where the electric motors are made, but they showed us an Easter egg. It was in the presentation. And you got the chance to see, this one here is from the Chevy Bolt. This technique was actually invented by General Motors, but not widely used. But this, right here, that's the joining point for the hairpin. And it's just like that. It's a hairpin that kind of winds its way in. You can see it. I got 2 different ones. This is the actual hairpin here. And then it comes through the other side. And I got it. And then it's laser welded on the opposite side. And that's what gives you your connection. So this is totally automatable, 100% automatable. And depending on who you talk to, this is anywhere from 20 to 30% more power. This is a really good idea. They didn't talk about it, but they showed it as an Easter egg in the videos. Yeah, and I'm telling you what, this is brilliant.
The reason you get there is you get better fill factor. So fill factor is these spaces right here are filled with more copper. There are some benefits to skin effect, but essentially if you could put more copper and vary the thicknesses of your hairpins based on the application and need, you can more carefully tailor this to the needs of your platform versus the wire ones or the wire wound ones. Typically have a lot of gaps and spaces in between all the circle wires.
Right.
Yeah.
Just throw it on the floor and get through these things. The other thing that I think was kind of important was the one that Cory spotted across the aisle. So I'm going to let him talk to you about it, but this was huge for me.
We got a tour of the factory, and the tour was similar to what we saw when
wide aisle tour.
Yeah, where we went to stations and they had different people in casting and stamping go over their general processes, but they weren't revealing anything new. So Sandy and I had our eyes peeled, looking around through everything to see if we could see anything that stuck out to us. And there was another group that was ahead of us, about 50 or 100 feet, and it kind of got backed up as we were going into the motor section. So they stood us there in waiting at like this juncture point inside the building. And I look across the fork truck aisle, and there's a glass cell, probably 30 by 30.
Probably, yeah, about
30
that,
by 30. But I could see in there, and on the racks, I saw packs of chips that looked like this that did not match this form factor. So first of all, Sandy and I you've seen this. This is the inverter from a Model 3 or a Model Y or a Model S.
Or a Model S or anything else. Everything's the same.
Where a lot of the power electronics are placed in here, and then you have your discrete IGBTs or MOSFETs, which are bonded to this aluminum plate. What we saw was a different form factor for this that ended up having 24 spots. Now this actually has 24 spots. I was a little mistaken. I remember 18 because on the induction machine they have 18. So you see there's 6, 6, and 6. So it had the same number of spots. It had 24. Wow. And but the shape of it, the fact that this whole section was separate, and they were doing shear testing on it.
Yeah.
And the patch for the discrete chip and the size of the chip was smaller. So they said 75% reduction in silicon carbide. The chips were taking up a much smaller form factor. So what I could see from like 30 feet away was the same number of spots with smaller chips, and the whole thermal unit, it had 2 thermal ports, 1, 2. The thermal unit was not integrated into the casting anymore. It was separate. It looked like 2 stampings with the ports integrated into an aluminum lower housing.
Right. But the big thing was it had a different form factor. This thing here has a look, and if you're an engineer, and Cory and I are, if you see something that you're expecting to look like this, it registers you in your mind. But what we saw was something that was a rectangle.
Yeah.
It looked entirely different. So Cory spotted it first, then he trotted halfway in, and then I went right in. I wanted to see what was going on. And this configuration, or the configuration that they had coming up, looks like totally different. It looks like a scrub on this.
You may say, why is that important? And the reason that's important is Tesla currently uses this generation of powertrain on all their vehicles. The Model S Plaid uses this, the Model 3, the Model Y, the Model S, the Model X. It's already, in our opinion, world-class leading in their ability of cost reduction and reuse, and the ability to apply this same powertrain, gear train, inverter strategy on all their different models, whether it's a rear-wheel drive, standard range Model 3, whether you have a front-wheel drive unit that is an induction machine instead of internal permanent magnet, they're still using this architecture. It shows me that they're working on, this would be their 4th generation, because this is 3rd. Because if you go back to the Model S and Model X, there's been multiple generations. So I know there's been a lot of focus on hardware but a new generation of powertrain means that they're not going to be happy with the status quo, because Tesla could still have manufactured this type of drive unit for another decade and still probably been competitive with most of the OEMs in the world. So many of the OEMs that are trying to catch up or emulate what Tesla's doing, they're now just getting there. And another thing from the presentation, 75% reduction in silicon carbide, and roughly $1,000 cost for the drive unit. $1,000 cost. Now imagine you are a tier 1 supplier and you supply drive units, gearboxes, motors, inverters, and you're charging $2,000, $2,500, $3,500, yeah,
average.
for a unit.
Right.
And now Tesla just said it's going to cost us $1,000. Now, when you walk into another OEM and try and sell your $2,000 unit, they're going to say, "Hey, how can Tesla make it for $1,000 bucks?" So this will be one of the hottest motor teardowns ever. So we specialize in tearing down these drive units. We'll get one eventually.
Yeah.
We'll tear it down and we'll verify whether it's $900, $1,100, $1,300.
Right.
But that's big news.
Well, the big thing is, if we put this into context, I mentioned before that I worked with pretty much every car company on the planet. One of the guys that really impressed me was E.G. Toyota. And that was the grandfather of the guy that just got removed. And he said something that I wrote down, and I use it all the time. Our current success is the best reason to change. We have to be permanently dissatisfied in order to get better and better and keep ahead of the competition. This is a good example of the old Toyota's approach to getting the job done. Permanent dissatisfaction. They're always looking to try and get better. And that brings us to the next one, which I was totally blown away at. This is a 4680 battery. This one is a wet cell. I can guarantee you that because we've taken them apart and they're not anything.
There's electrolyte in it.
It's an electrolyte in it. But what we looked at was a dry cell. And unfortunately, we weren't allowed to take pictures. But picture something that's about 1 meter in diameter and about 2 meters in length. So 3 by 6, 3 feet by 6 feet. And here's the deal. How many bands did they have? 1, 2.
So they had 8 bands.
8 bands.
But what they do is they slit it in the middle.
Right.
And they slit it in the middle of the powder, and they make 16.
But it's dry. There's no electrolyte used. So here's the thing. Or the electrolyte is.
It's a dry process
Yeah.
to form the cathode and the anode.
Right.
They all have electrolyte.
Yeah, it has an electrolyte, but everybody else is using something that requires you to boil away a solvent that really isn't good for the environment. These guys have figured out how to compress it and put it together. Now, by accident, or maybe it was another Easter egg for us, we found out what they use. And so we're going to try and back that into how does that process work. We'll try and make that happen in the future. But watching how they put it together, the difference between one basic unit that does all the spooling and whatnot versus a factory, a huge factory full of equipment with chemical reprocessing and everything else, it's mind blowing. The footprint alone between the two is like the difference between a football field and some kid playing hopscotch. That's the difference. We're looking at a huge amount of change to go to the new 4680, and that brings me to the other one. You know, I know that everybody. Oh, the form factor, Sandy. The form factor. Oh, the form factor. You know what? Look at this from a form factor standpoint. If I lose one of these, okay, I lost 3 volts. But if I lose one of these, I lose a brick that's about that size. And guess what? If this thing starts on fire,
it propagates.
It propagates. It's going to go as big as it can, and it's going to go through that module. I don't understand this. I can't imagine why anyone would take the risk.
Yeah. So this is multiple layers.
Yeah.
But if you unroll this, it's what, 3 meters?
Yes, they said 3.5 meters, I think it was.
Yeah, 3.5 meters.
3.5 meters. So 10 feet.
Yeah.
But at the end of the day, I was impressed with the.
And technology aside, why does it matter? You may be watching this like, who cares, Sandy? Who cares, Cory? This is why it matters. They're stamping those cans inside that plant. We walked by.
Right.
And they were actually stamping them as we were standing there.
Right.
They're rolling up the anode, they're rolling up the cathode inside that plant without a 100-yard oven.
Plus upstairs. They've got the powders that they need.
Yep.
They grind everything up. They put it all together. They do the chemical formulation on the 4th floor that they say isn't there, but really is. And then that powder goes down into those machines, and they're cranking this stuff out. And I'm telling you what, we were watching them, and they spin pretty fast. I mean, this is really, really brilliant.
Yeah. Back to my point. Sorry, Sandy. If you look at this Rivian cell, Rivian buys this cell. And if you buy it, that means you're paying a profit margin to that supplier. That supplier exists and makes profit because that's how companies exist. So if Tesla's making their own cell, where does that profit cost go? It's eliminated. It's passed on all the way up through the vehicle. So the more vertical integration you have, and the most expensive part of the car is the battery. So they just wiped out one of the largest pieces of profit loss by doing it themselves.
Right.
Then they also build the packs themselves.
Right.
Most people outsource pack assembly.
Right.
There's integrators that build packs. They're building the packs themselves. They're building the seats themselves. They're doing IPs themselves. And this is the advantage.
And the castings themselves and all the other things that everybody else. I mean, you talk to any Harvard guy, any Harvard MBA, and he'll tell you for sure, you got to outsource. You know what? That dance is dead. I don't know if anybody has got a brain, let me rephrase that. Anybody with a brain should be able to see the difference between, I'm doing this internally. I understand the technology cold. I understand and formulate my own chemistry. I make my cans, I know exactly how many I'm going to be able to make. I don't have to worry about trying to control the market or find out if a ship sunk and all my batteries happen to be in it. I've never really been, and quite frankly, I'm going to turn that around. I've been criticized on a number of TV stations and whatnot. I can remember when McElroy, Sandy, didn't you know? I mean, really and truly, everybody was so sunk, dead positive that you had to outsource. And I kept asking what was the reason for that. Well, we can get it cheaper. Well, you can't. It's not possible. That's trickery that comes into your finance department. But here's the deal. If you can make them yourself, and you can control the process yourself, and you can basically come up with new formulation of what goes into this bath yourself, you're going to lead the parade. Everybody else that's going in this direction, you're buying chemistry from somebody that is giving you a lot of smoke. You're out of your mind. And by the way, everybody that makes these, all the producers that make these, they also make those. But they don't make as much money on that. They want to sell this. And that's where a lot of folks are going down a primrose path. And I actually got to hand it to GM. They're switching one of their battery plants from this to that. Hopefully Ford will do that too. But at the end of the day, to me, seeing that dry process was a giant revelation. That to me was just phenomenal.
The next thing I want to talk about, Sandy, which I thought was the biggest announcement of the entire event, was a slide that they showed was how many electrical modules were owned and controlled by Tesla over the various models over the course of development. And it showed the Model 3 and the Model Y, and I might get this slightly wrong, but it was somewhere in the 50% of the modules were owned by Tesla on the Model 3, and it was 60 or 61% on the Model Y. The Cybertruck was 85%. Now when we buy modules, these are electric modules to do all the important things, whether that's your liftgate control, your door modules, your body controller, all the little things throughout the car, ADAS, the controller for the infotainment. 85% on the Cybertruck will be owned by Tesla, but they said the next generation vehicle, 100%. And the reason why that's important is it can minimize the wiring length, this is what they talked about, but I think it's more important for changeover to 48-volt architecture. Because the entire supply base has been 12 volts for decades and decades and decades.
Forever. Ever since they put a starter into the car, or sorry, let me rephrase that, a battery into a car.
Yep.
It's been a 12-volt battery.
Yeah, and let's not mistake this with other 48-volt mild hybrid systems which have been deployed over the last decade and a half. Those are typically used only for belt start generators,
Right.
and then high amperage systems like high amperage steering racks, or maybe a brake-by-wire, which are going to draw a lot of current and amperage. So those were just 2 or 3 or 4 systems were ran by 48 volts, but the rest of the car, your door locks, your switches, your lights, or your HVAC, which draws less amperage, but some,
Yeah.
still all 12 volts. So now imagine this. We are at a point in 2023 where the entire car industry is 12 volts. We can look back at this video in maybe 15, 25 years, and the entire auto industry most likely will have shifted to 48 volts.
I'll bet you it's faster than that. I'd say that if we
Well,
look
no,
at
this is
five to-
everyone else.
I'm telling you, I think it's going to happen a lot faster. All they need, look, we talked about the castings, those wherever the hell that thing is, for 10, 12, 14 years. Nobody went for it until Tesla did. These guys came out with this big casting here and talked about the other castings that are coming down. And 2 years, like in basically 2 years, Idra's got a shitload of new orders. I guarantee you, everybody on the planet, I can carry, I think right now, all the guys that do all the solenoids and all the 12 volt whatever stuff, they're sitting there going, and they're going to make the switch. Because there's another thing you should know too. Let's look at these two. I want something a little more dramatic. Let's look at these two. That would be the wire size for 48 volts. This is the wire size for 12 volts. I need more wire. It gets heavier. Every time you move to a slightly higher amount of voltage, that's what pushes the amperage through, you can get away with a smaller wire size. Think about it, okay? Now these wires are normally really tiny. I could never show you because they are tiny. But any time that you can reduce the size of anything and reduce the weight of anything, you're going to get more range. The 48 volt system has been talked about since I joined Ford Motor Company in 1978. And nobody did anything about it. Oh, we can't get the suppliers to move on that.
Yeah, and the reason you get more range is not because you're not going to reduce the amperage and current needs of whatever you're doing. If you're steering the car, you're going to need the same amount of amperage. So if you jack the voltage up, the wire size drops. So the cost and the weight of the wires drop. So now here's how this actually makes a difference. If you can cut out 15 to 25 kilograms of copper out of the car, now the vehicle weighs less. So if the vehicle weighs less, it has a cascading effect. Now the amount of effort needed in that steering rack drops by maybe 0.5%. The whole vehicle benefits from it.
Right.
Now the vehicle's lighter, so you can get more range with slightly less batteries. Now you have slightly less batteries. So in order to truly make a next-gen vehicle that's low cost, you have to do everything the best way possible.
Right.
And Tesla decided that they're going to forego the entire supply base and said, we are developing automobiles the way they should be developed. We're not relying on the vestigial past of 12 volts. I think it's the biggest takeaway from the entire event.
I think that's true, and we save the best for last always, and that system is going to make a gigantic difference. But even more importantly, what's going to happen? Well, first off, by the way, there's another thing you should know too. When you drop the wire diameter by about a half to get to 48 volts, copper is one of the more expensive components and one of the more heavy components that are in vehicles. That's why a lot of people will swap high power from copper to aluminum. Aluminum conducts as well, but not as well, not as good, but it weighs a whole lot less and it costs a lot less as well. So moving to the 48 volt system is going to put every component supplier on notice. And I'm telling you, right now, I believe that there's got to be every boardroom at every tier 3, those are tier 3 kind of guys, tier 3 in some cases tier 4 suppliers, they're going to be in a panic attack. How are we going to get to 48 volts? They probably looked at it, but they probably never thought they'd ever have to do anything, because in essence, engineers aren't allowed to design for 48 volts, and purchasing agents were going to say, I can get a cheaper one if it's a 12 volt. And that's kind of like the way it works, unfortunately, in the auto industry. So the one other thing that I wanted to maybe bring up was the Mexican plant. I believe that the Mexican plant is a genius move, because the labor rates are lower. Actually, we've done studies that found that in some places, in some situations, Mexico is cheaper than China. Why go to China if you can get to Mexico? And if they're going to make that $24,000 car, like they said they were going to, then I believe that Mexico's the right facility. And this new facility, I believe, is going to have the new vehicle in it, and it'll have all these changes that we've been talking about, and probably a whole lot more. I think there were surprises. Actually, I want to look closely at all these videos, because there's Easter eggs everywhere. We walked around, and there was a lady that kind of tagged along with us. Her name was
Erin Riley.
Erin Riley. Oh, you got the last name too. So anyway, when Erin was she's a financial person, and I was trying to describe what it looks like inside this thing, and I wasn't doing a very good job. And I look over, and here's one sitting without the collector cap on, and you can see the tabs. And I pick it up, and I showed her how it worked and whatnot. And just for grins, it's dead. It was not alive. So at the end of the day, this is an Easter egg. I think that Tesla was intentionally putting things out there so that if you were savvy, you could figure out what was going on. They were throwing us a bone. Easter eggs are to me phenomenal at Tesla. And quite frankly, we didn't stick around for the questions, because the first couple were pretty lame, and I didn't want to. Are you going to have 4 wheels on this car?
So that makes 2 meetings that Sandy and I were at, where Elon was speaking, where we left early.
Yeah.
One is SpaceX.
Well, SpaceX was.
Remember, he says if you're not adding value, you should get up and leave.
Yeah.
Or if you're not getting value from it.
Yeah.
So we weren't adding value when we were in SpaceX.
Well, when I was at SpaceX, I gave them that one idea, which I believe they implemented. So that was fine. But I was dead dog tired. I couldn't even see straight after that thing. We'd been up for 20 hours or something. It was ridiculous amount of travel that we went through. But at the end of the day, I thought you were talking about when we went to the Cybertruck. We couldn't get in. Everybody was in that room. We got there late. Oh, that's the other thing. I asked about. I wanted to see the new
Hydra presses.
Hydra presses, and I asked the guy. I said, "Where's the? Are we going to get a chance to see the Hydra presses?" No. Why not? I said, "Well, where are they?" And he said, "Oh, they're over there." I said, "Can I just skip over and have a look?" He said, "See those 4 big guys there?" He says, "They aren't going to let you by." So that was the only thing that I was really kind of disappointed at. But I can imagine why they wouldn't have wanted to allow people over there anyway. They wouldn't have known what they were looking at. We did get a chance to see these, the bigger castings and whatnot. I was impressed because they, again, another Easter egg. These weren't trimmed, so we got a chance to see all the gates, the runners. The cooling, sometimes what you need to do is wick away heat, and you put like a radiator or a heat sink or whatever. It goes right in with the casting, and I was really impressed by getting a chance to see that, how they've developed that thing. But I mean, every time I turned around, there was another surprise. It was a wide aisle tour. We didn't get a chance to. Actually, in fact, they said that 75 or 80% of the people weren't there. They were asked to stay home, right?
No, only in final. Everything was moving.
Everything was moving, but it was like non-essential personnel didn't have to be there.
It was non-essential.
anyhow, I thought it was great. I'm not going to sit around and listen to financial guys because they said they weren't going to talk about the financials in depth and next quarter and stuff like that. And most of the people we had talked to were deep financial people, but shallow when it came to technology. And we were way at the back, so we would have never got any questions answered. So we left.
So, in summary, Sandy, we were there.
Yeah.
We got invited.
We did, and I thank you so much, Tesla, for letting us in.
We saw a lot.
Yeah.
And the long-term nature of the presentation really struck me. I said this on stage, I feel like Tesla no longer has an imposter syndrome. I feel like for the first 3 to 5 years of their existence, they were just trying to show the world, I say 3 to 10 years of their existence, they were trying to show the world that they can do it, particularly when they were trying to produce the Model 3. I think they pushed them out to the market a little early when they had the fit and finish issues.
Yeah.
But now they're kind of hitting their stride.
Yeah.
1.3 million vehicles last year, on pace for probably 2 million this year. Developing a whole new architecture will allow them to hit all sorts of new markets, particularly the low end. They could have just said, hey, we're going to go after large SUVs next, which would be a highly profitable endeavor, but they're focused on the world, because if they're building in Mexico, I believe that plant is going to produce for other regions. If you can produce that low-cost car and sell in South America or Mexico itself.
Well, look at it this way: the plant's going to be the same size as the existing plant that they've got in Texas. If it's the same size and you're making a smaller vehicle, it'll have less options and it'll have less parts. Guess what? It's going to be
a couple million.
Yeah, right? I'm thinking 2.5, maybe even 3 million out of that plant. People are going to, oh, you can't make it. Yeah, you can't make a 3 million out of a plant. But you know what? You can't make anything out of 48 volts. I heard that too. And you know what? Oh, you can't make, these batteries can never be made. Every time somebody opens their mouth and says, that can't happen, Elon shows up with, oh, here, you want to look at that? Well, you know, I don't think that's going to work. And it's always the same. You want to be a naysayer? Go ahead. Go and be a Hindenburg. I don't give a rat's ass. At the end of the day, eventually, you're always going to lose. Always. Because, especially if you're betting against Elon Musk. Don't do it. Yeah. So
that's it.
With that, I guess we can say goodbye. And don't bet against Elon Musk. So anyways, I would like to thank the people at Tesla that got us in. I'm eternally grateful. These were like I say, this is the hottest ticket in North America, or actually the world.
Someone offered to buy this from me afterwards for $500, and I turned it down. So it's already worth $500, Andy.
Well, there you go. I'm not selling mine. But anyways, thanks for watching, and we'll come back to you with maybe some more stuff in a little bit. Thank you.